statisticians, we are looking at section 1C, so displaying quantitative data with graphs. There's a lot to look at. Today we're going to be focusing on dot plots and shape of the distribution. So, before we get started, I want you to take a look at, we have seven different dot plots here. So I want you to take a look at the example and answer these questions. What are the most important differences you see in the various cities it gives you? So, okay, so it might have been hard for you to kind of describe some of these differences or say them. So I tried to think of things you guys might say. So for what is the most important difference between cities A, B, and C? So when I look at those, we have A, and I'm not going to box it, it might give us that good visual, B, and C. So I'm kind of assuming maybe you said something like the location or maybe the values it contained. What you are really looking for there is the center. So I don't expect you to have known that, but this is me telling you that word that you maybe were struggling to describe it with, it's the center of the data, is different. And then it was, what is the most important difference between C and D? So C, kind of looking at it versus D. Hopefully you were kind of thinking like the kind of spread out it is. So C and D are kind of, one's a little closer together, D's very like thin. What you were looking there for that word was variation. So the variation in the data. 3, what 2 important differences between D and E? So if we look at D and then E, so I'm thinking you said something maybe along the lines of like E has a lot of dots stacked and D is a lot more spread out. So there, once again, you're kind of looking for shape and variation. If you said anything about like these dots that are really far away, you're looking for the word outliers. And then lastly, C, F, and G. So if we look at, here is G, C, and F. So once again, if you're struggling to find the word for that, that word is shape. The shapes are very different. So that's kind of foreshadowing of the different things we'll be talking about. Maybe not today, but in this section is how to describe distributions and differences in multiple distributions. So if you couldn't do that, don't worry. Okay, so, oh, yeah, I'm covering all. Okay. So now we are looking at going specifically into quantitative data. We have 2 different types of quantitative data. So we have discrete variables and continuous variables. So discrete is a quantitative variable that takes a countable set of possible values with gaps between them on a number line, and it is a discrete variable. So I think of discrete variables as like either integers slash whole numbers. The most important thing is when it says there's gaps on, because there's gaps, think of that as like all those decimals in between, we don't use them with discrete variables. So an example of a discrete variable would be, so Um, this kind of breaks what I said about it being integers or whole numbers. An example would be shoe size. And so if we think about shoe sizes, we do use a decimal there, but we only ever use a half. You're not going to have a shoe size of 6.14. It's either 6 or 6.5. So there's gaps there. So we'll throw in half decimals. So versus a continuous variable is a quantitative variable that can take any value in an interval on the number line. So this, think of it as like temperature or weight. We measure using those more than just half a temperature or half a degree or half an ounce or pound, whatever you're weighing it. So that's kind of that difference there. And I'm sorry, my handwriting is atrocious on this, but I'm using a tablet. Um, so one way that we can display this data is a dot plot. So which we've seen in class. So um, here it's pointing out there are two data points that have 10 ppb of lead. So remember, each dot represents an individual measurement. So we've been building dot plots, so this shouldn't be new. We draw and label our axes. You scale it, so similar to when I set it up in class. It's all going by the same thing. In this case, it's tens, and then you plot your values. So nothing new. You won't have to build dot plots typically too often, but every now and then. So now we're getting into how do we describe data, and we're starting with shape. So we have a couple of different ways we can describe the shape. So we have roughly symmetric, if the right side of the graph is approximately mirror of the left. So I think of that like a bell curve. A distribution is skewed to the left if the left side of the graph is much longer than the right side. So I think of this is going to sound really weird, but I think of it like as if I'm picturing my foot. So if you picture like the toes on your feet, your left foot kind of looks something like that. So that tail is longer on the left, it's left skewed. A distribution is skewed to the right if the right side of the graph is much longer. So like if you picture your right foot, it kind of looks something like the toes, kind of looks something like that. So that's how I remember left or right skewed. So, and then this is just the direction is always towards the long tail. So there's this kind of longer, thinner tail, left skewed, longer, thinner tail, right skewed. So, and then we have one last way. A distribution is approximately uniform if each value is about the same. So uniform, thinking of it like kind of all one flat line. Well, you could say this is roughly symmetric too. This is, we would pick uniform over that. Um, okay, before we get into that, I do want to talk. We don't hear, this comes up every now and then, so I want you to be familiar with it. So we also have either, you don't need to make a flashcard for this. Sorry, I don't know why my pen's not writing. Okay. Okay, so we do have what we call bimodal or multimodal sometimes, and so that is just we see multiple clumps of data. So these are what's making it even bimodal. Or if we had more, then it would be considered multimodal. If you want to make a flashcard and draw the picture, you can, but up to you. So now describing distributions. So we're trying to look for patterns and anything that is outside of the pattern. And these are the four things. If you're ever asked to describe a distribution, these are what you have to give. And so I like to use interchangeably with instead of variability. I like to think of that also as spread. And I use a different order than this. I use socks. And I always say, don't forget your socks. And we actually give it a plus. Socks plus. So it's your shape, outliers, center, spread, aka variability, how spread out is the data, how much variation is there. And then the plus is context. You always have to make sure you give context. So here's an example done for you. So before I even look at that um, example on the right, like I am looking at kind of this shape and I'm like, okay, that is right skewed. So we want to say the distribution of lead level, that is your context, is skewed to the right with a single peak at 0 ppb. So that is describing it's skewed to the right. You, that single peak is a good thing to have. It's nice to have. If you get it's skewed to the right, I love it. And then we have, when I look at the center, we'll talk more center later on, but you want to give either the median or the mean. So center, and we'll talk about how you know which one. Center, you either give median, I'm sorry, that's hard to see, or mean. So here they've chosen to give the median value, and you want to be specific. So, and once again, they're using that context, the lead level. Variability. So in this case, they're just giving, it goes from 0 to 104. So 0 is that lowest dot, 104 is that dot over there. We'll learn better ways, but for now, that is how you give, and once again, they're giving specific context lead levels. And then they're saying how spread out it is. And then outliers, we'll talk more about outliers, but that's a point that's far away from the rest. So that outlier is over here. So there's one obvious outlier at 104. And then they're unsure. So they say the two lead levels may also be outliers. We'll talk about how to find outliers later on, but the key right now is describing distributions, and that's don't forget your socks plus context. So here is another example of when you have to compare. So if you are comparing, then you want to make sure you use comparative language like greater than, less than, about the same as, and then once again, don't forget context. So here's another example, and this time they are using that socks for spread, aka variability. I don't think we have a picture of the distributions they are talking about. No. But they're comparing the distribution of household size. There's your context. For South Africa is skewed to the right with a single peak at 4 people and a clear gap between 15 and 26. The distribution of household size for the UK sample is roughly symmetric. So just kind of saying exactly what those distributions look like. Outliers. Saying if one has outliers and the other does not. And then once you get to center and variability or spread, that's when you can really use that larger than, less than, about the same. So I want you guys to try your best to compare these distributions. I would say make it easy on yourself. Use the median, which is the middle. The middle, so if you were to like count up the total dots, the one in the middle is your median. So, okay, so here I have gone through the SOCS plus context. The distribution of test scores for class A is roughly symmetric with a single peak at 15 points, while the distribution of test scores for class B is left skewed with a single peak at 20 points. The distribution of test scores for Class A does not appear to have any outliers, while the distribution of test scores for Class B has an obvious outlier at 6 points and two potential ones at 11 and 14. So if you were to compare my example to the example above, I'm almost copying it word for word, just filling in with what's specific to these. And that's seriously how it is every single time that you're either comparing distributions or just describing a distribution. It's even easier when you're describing, you just have one. So then center, the test scores for Class A tend to be lower, median of 11 points, than Class B median of 19 points. And so once again, I just found literally the middle point for each of those distributions. And then the test score for Class A vary less, 12 to 18. That's where our dots range. Then the test scores for Class B, 6 to 20. So it looks like writing a lot, but once you get the flow of it, it's really always just the distribution of blank and then giving whatever thing you're trying to describe. And that's where we're done for the day. I know today's a little bit longer, but working on homework. And then it should be Friday, so have a good weekend, and I will see you all on Tuesday because Monday is Labor Day. Once again, email me if you have any questions, but get your homework done and then have a great rest of your day.